Ever seen a river flow under the ocean? It sounds like something straight out of a fantasy novel, but get this, it's real. We are talking about massive, flowing bodies of water that carve canyons into the seafloor, create their own ecosystems, and even influence our planet's climate. Today, we are diving deep to uncover the secrets of these hidden ocean rivers. How do they form? What kind of life do they support? And what can they tell us about the future of our world? Stick around, because what we are about to explore will change the way you see our oceans forever. So, how is it even possible for a river to exist within an ocean? It all comes down to a simple but powerful principle: density. Imagine pouring honey into a glass of water. The honey, being much denser, sinks and flows along the bottom. The same thing happens in the ocean, but on a much grander scale. These underwater rivers aren't made of fresh water, but of water that is significantly saltier, colder, or carries more sediment than the surrounding seawater. This difference in density is the engine that drives them. One of the most spectacular examples is the Black Sea Undersea River. Discovered by scientists from the University of Leeds, this channel is a true giant. If it were on land, it would be the sixth largest river in the world in terms of the volume of water it carries. It flows along the seabed of the Black Sea, carving out deep channels with banks and floodplains, just like a terrestrial river. The water in this river is much saltier and denser because it originates from the Mediterranean Sea, spilling through the Bosphorus Strait. As it enters the less salty Black Sea, it sinks and begins its incredible journey along the ocean floor, carrying nutrient-rich sediments with it. Another fascinating mechanism is the formation of what are called turbidity currents. Picture an underwater avalanche. When a large amount of sediment, like sand and mud, gets stirred up on a continental slope, perhaps by an earthquake or a storm, it mixes with the water to form a dense, turbulent slurry. This mixture is heavier than the clear water around it, so it rushes downhill at incredible speeds, sometimes over 60 miles per hour. These currents are so powerful they can snap transatlantic cables and carve out some of the largest canyons on Earth, like the Monterey Canyon off the coast of California, which rivals the Grand Canyon in size. What's left behind is a permanent scar on the seafloor, a testament to the immense power of these flowing underwater phenomena. Scientists use advanced sonar mapping from research vessels to create detailed 3D images of these canyons, revealing the intricate paths these sediment-laden rivers have taken over thousands of years. It's like being an archaeologist of the deep, uncovering ancient riverbeds hidden beneath miles of water. These rivers aren't just geological curiosities, they are vital highways for marine life and crucial components of the global climate system. Think of them as express lanes on the ocean floor. The currents transport nutrients and organic matter from the shallow coastal zones into the barren deep sea. This delivery of food is a lifeline for deep sea ecosystems, which would otherwise be a virtual desert. Organisms like deep sea corals, sponges, and countless species of fish and invertebrates congregate along the banks of these underwater rivers, feasting on the bounty they provide. Researchers deploying remotely operated vehicles, or ROVs, have captured breathtaking footage of these oases of life, thriving in the eternal darkness of the abyss, all thanks to the resources delivered by these flowing currents. It's a perfect example of how interconnected our planet's systems are, where a flow of dense water can create a thriving community in one of the harshest environments on Earth. Perhaps the most famous and impactful ocean river of all is the Gulf Stream. While it's not a river on the seafloor, it's a massive, fast-flowing current of warm water in the Atlantic Ocean that functions like a giant river within the sea. Originating in the Gulf of Mexico, it travels up the eastern coast of the United States and across the Atlantic towards Europe. This colossal current transports an incredible amount of heat, more energy than is produced by all of humanity's power plants combined. And its impact on our climate is profound. The warmth from the Gulf Stream is what gives Western and Northern Europe a much milder climate than other regions at the same latitude. For example, London is far less frigid in winter than, say, parts of Canada that are on the same latitude, and we have the Gulf Stream to thank for that. It acts like a global conveyor belt, redistributing heat from the equator towards the poles, playing a fundamental role in regulating Earth's temperature. However, this critical system is facing threats. Climate change is causing polar ice caps to melt at an unprecedented rate, releasing huge amounts of cold, fresh water into the North Atlantic. This influx of fresh water can disrupt the density-driven circulation that powers the Gulf Stream and the larger Atlantic Meridional Overturning Circulation, or AMOC, of which it is a part. Scientists are closely monitoring this, because a significant slowdown or collapse of this circulation could have drastic and unpredictable consequences for global weather patterns. We could see more extreme winters in Europe, altered rainfall patterns affecting agriculture worldwide, and accelerated sea level rise along the US East Coast. The study of these ocean rivers, therefore, isn't just about exploring a hidden world. It is about understanding the delicate balance of our planet's climate and the potential impacts of our actions. The discovery and study of these underwater phenomena are a testament to human ingenuity and our relentless curiosity. Early evidence came from snapped telegraph cables on the seafloor in the early 20th century, which led scientists to suspect that powerful, unseen forces were at work. But it wasn't until the advent of modern technology, like multi-beam sonar and autonomous underwater vehicles, that we could truly visualize and understand these systems. Today, scientists can map the seafloor with incredible precision, revealing channels and levees that stretch for hundreds of miles. They use sediment cores to analyze the layers of sand and mud deposited by past flows, reconstructing the history of these rivers over millennia. And with advanced computer models, they can simulate how these currents behave, helping to predict their impact on both deep-sea environments and the global climate. Each new discovery, each new piece of data, adds another layer to our understanding of the ocean's complex and dynamic nature. It is a field of exploration where the next major discovery could be just one sonar ping away. From the salty depths of the Black Sea to the sediment-filled canyons of the Monterey Bay and the globe-spanning warmth of the Gulf Stream, these rivers of the deep are a powerful reminder of how much we still have to learn about our own planet. They're not just geological oddities, but are integral to the health of marine ecosystems and the stability of our global climate. They are hidden architects of the deep, shaping the very foundation of the ocean floor and sustaining life in the most unexpected places. The next time you look out at the vast, seemingly uniform surface of the ocean, remember the hidden world of motion beneath. A world of powerful, flowing rivers, carving their paths in the dark and silently shaping the world we live in. Thank you so much for joining us on this deep dive into the world of ocean rivers. It's truly a fascinating subject that shows how dynamic and mysterious our planet is. If you found this journey as amazing as we did, please hit that like button and subscribe to the channel for more explorations into the wonders of science and our world. And don't forget to ring the notification bell so you never miss an adventure. What other ocean mysteries do you want us to explore? Let us know in the comments below. Until next time, stay curious.